Hi everybody, I'm going to go over the notes with you for chapter 9 section 2, which is about the reciprocal function family. Our two objectives are to graph reciprocal functions and to graph translations of those reciprocal functions. See if I can videotape this and navigate through the slides. I'm going to skip a few of the slides, but functions that model inverse variations belong to a family whose parent is the reciprocal function f of x equals 1 over x. X can't be 0 because you can't have 0 in the bottom of a fraction. The general form of a family member is y equals a over x minus h plus k, with a single real number h missing from its domain. The inverse variations y equals a over x are the stretches and shrinks of the parent reciprocal function. Okay, so some of that will make a little bit more sense as we go through the notes more. Okay, make sure I didn't skip a slide. Okay, so here's our first example. Sketch a graph of y equals 6 over x, and x can't be 0, again, because 0 can't be on the bottom of a fraction. So one thing you can do is just make a big table of values and plug them in and see what you get. So when x is negative 12, you plug negative 12 in there and you see what you get. When you plug in negative 12, you get negative half. When you plug in negative 6, 6 over negative 6 is negative 1. When you plug in negative 3, 6 over negative 3 is negative 2. When you plug in negative 2 right here, you get negative 3. When you plug in negative 1 right here, you get negative 6, and so on. Now, the thing you have to be careful with is that you can see down here from the graph, there's two separate sections. You can't just put in all positive x's because you would only get this side of your graph. You have to make sure you also put in the negative values to get both branches of the graph. Those are called branches. It says graph all the points, connect them with a smooth curve to the left of where x equals 0 and another smooth curve to the right of where x is 0. Each part of the graph is called a branch. The x-axis is a horizontal asymptote. Remember that an asymptote is a line that your graph approaches but does not cross. So the x-axis is a horizontal line that the graphs approach but don't cross. And also the y-axis is another vertical asymptote, which is a vertical line that your graphs approach but do not cross. Okay, skipping that slide. The branches of y equals 1 over x would be in quadrants 1 and 3. Stretches of that just means that instead of a 1 on top, they have an a number on the top. And if a is positive, your graph is going to stay, it's going to remain in quadrants 1 and 3. Your branches will always be in 1 and 3 as long as your top number is a 1, or if there's a different number, as long as that a is positive, it'll stay in quadrants 1 and 3. If a is negative, then it would go to quadrants 2 and 4. Then it would just flip over into those two quadrants. Okay, so here is an example. Draw the graph of f of x equals negative 4 over x and describe the properties of the graph. So the graph of y equals 4 over x is a stretch of 1 over x by a factor of 4. So over here in this graph, let me zoom in a little bit. In that graph, the black graph is the y equals 1 over x, okay? That's the two branches in quadrants 1 and quadrant 3. X can't be 0, which means it has both these axes as your asymptotes that it doesn't cross. Notice that it always has this point 1, 1 here, and the point left 1, down 1, negative 1 is also on this graph. If it has a 4 on the top instead of a 1, it just stretches it by 4. So instead of going over 1, up 1, now it goes over 1, up 4, so way up here, okay? So it's just a stretch. That's what that 4 is doing. So if you change the 1 to a 4, it's going to stretch it. Now, if you have a negative 4, it's just the 4 over x being reflected. So if you take those pink ones over here and you reflect them into quadrants 2 and 4, you would have that. Let me see if I can move this up just a little bit. You can see a little bit better. There you go. Oh, went back down. So you can see a little bit better right there. The blue ones would be the negative 4 over x. It's just the pink ones that are reflected into quadrants 2 and 4. Okay, so now if you have a graphing calculator at home, I'd like for you to do this on your graphing calculator. Go to your y equals button, and the y equals button, I want you to put all of those equations into your calculator. Y equals 1 over x, y equals 2 over x, y equals negative 2 over x, y equals 0.5 over x, and y equals negative 0.5 over x. So it'll look like, let me see if I can put it in there. It'll look like that on your calculator. 1 over x, 2 over x, negative 2 over x, 0.5 over x, and negative 0.5 over x. Okay. Then it also wants you to go to your window and change your x max and min and your y max and min numbers to those. So remember the window button on your calculator is right there. So click window and change the window to -3, +3, and then y minimum is -2, y maximum is +2. So if you can do this on your own calculator, it's great, but if not, I'm gonna click the graph button, you're gonna see what it does. It's kind of a cool example when we usually do this in class. So first it's graphing the 1 over x, that's just the normal one. Then that one is the 2 over x that's been stretched by a factor of 2. The black one is the negative 2 over x, just a reflection of the red. The purplish color is the 0.5 over x, and then the green is the negative 0.5 over x, just a reflection of that purple one.